Agent Hunt has been assigned a new mission. Secure the containment unit holding 3 kilograms of unstable plutonium. Trapped on a tower, he is cut off from the extraction team by a huge drop. His orders are clear. Transport the bag, by whatever means necessary, to the extraction point using a single throw. Physics is the only thing, and projectile motion at that, between him and Project Warhead being completed. Let's decompose the vectors. So first we have a velocity initial and we decompose that into y and x directions. Therefore, we get an x initial velocity of 6.91 and we also get a y initial velocity by using the sine function instead and get 4.03 meters per second. Now we find the time of flight, so first we find the vertical displacement and plug that into the equation from kinematics, and we get a quadratic equation. After we plug this into the quadratic formula, as shown on the screen, we get that time is equal to 1.30 seconds. Now we find the horizontal range. So we know there's no horizontal acceleration, and therefore we can just plug it into this equation, and after we plug in the values, we get 8.95 meters. Now there has actually been a little miscommunication between the team. The team's actually waiting at the bottom of the zone and they're wanting to know how fast it's moving. Let's do the forces breakdown. First we have our block, which is at 30.27 degrees at theta, and we have these components. Now we're going to rotate the coordinate system so that it's normal, and we're going to break gravity into components. So then we have mg cosine theta and mg sine theta, as well as the previous forces. Now to solve for them, what we do is first we find the sum of forces, then we sub in the values until mass cancels, and then we group this to get this equation right over here, and we find that acceleration is 3.25 meters per second squared.